there, it's Mrs. Tremblay. It's time for 8.4 samples and populations. So those are two vocabulary words that you need to be aware of and know the difference between, and that's what this first part of the lesson is about. What's a population? Population is an entire group of people or objects, and a sample is a part of the population. So I just kind of picture this as, I am sure that you have gone to Sam's Club or Costco on a Saturday or on a Sunday, and they have all kinds of free samples, right? So let's say you have orange juice. They'll have a big container of orange juice, and they pour you a little cup of it. The big container of orange juice would be considered the population, and a tiny little cup of that orange juice would be the sample. So populations will always be larger. The population is the whole thing. A sample is just a piece of the whole thing. So all of the students in a school, all the students that go to JMS, that would be considered a population. One of the classes in the school, that could be considered a sample of the entire school. All right, so moving along, we want to be able to apply this now. An agency wants to know the opinion of county residents on the construction of a new road. The agency surveys 800 residents. Identify the population and the sample. So in looking at this, they chose 800 of the residents in this county. A county has more than 800 people that live there. And of those 800 people, 533 favor the new road and 267 oppose the road. When I ask you for the population and the sample, I'm not asking you about any of these numbers here. I'm asking you, based on this, what's the whole and what's the piece? So in looking at the population in this scenario would be all of the people in the county. So population is all county residents, all the people that live there. The sample that they chose, they interviewed 800 of the residents. So the sample would be the 800 residents. So if I'm asking you what the population is and what the sample is, I'm not really asking you for specific data values here. This just shows the results of it. I'm asking you, what is this out of, and what's the small piece of that? So hopefully that makes sense. All right, example 2. You want to know how many students in your school are going to the volleyball game, so we know how much pizza and pop we need to order for the concessions. You survey 50 students. 10 out of those 50 are going to the game. The rest aren't going. Identify the population and the sample. So population, you want to know how many students in your school are going to the volleyball game, and you ask 50 of those students. The population is going to be all the students in the school. So all students in the school. The sample is going to be the smaller number of those students that you asked, are you going to the volleyball game? And we said that was 50 students. So this is the entire population here, everybody, and this is the smaller value of people that we actually asked. And why do you ask a sample instead of the entire population? It would probably take a really long time to ask every single student in the school, hey, you going to the volleyball game? Okay, let me put down a tally. So that's what people do. They take samples of a population, and then they make predictions based on just the sample, because to ask everyone takes way too long. All right, so speaking of taking samples and making predictions, flip over your paper and take a look at the next section here. Reasonable samples. So if you're going to take a sample of a population, there are some certain criteria you have to look for. Otherwise, when you get your data, it could make a sample that is kind of not fair, or we could just pick a sample that will give us the results that we want. And you can't really do that. You can't make good predictions based on samples that don't fit the criteria. So what makes a good sample, or reasonable is the word that the textbook uses? It needs to be selected at random. It needs to be representative of the population. And it needs to be large enough to provide accurate data. So what this means is, for random, I'm not handpicking just the people that I want to ask. It's random. It could be anybody. Representative of the population means it includes everybody. So if I wanted a population of our school, I wouldn't just ask the 6th graders, I wouldn't just ask the 7th, and I wouldn't just ask the 8th. I'd need to ask 6th, 7th, and 8th graders. Also, I'd need to ask both males and females, not just all girls or not just all boys. So representative of the population means there's a little bit of everybody included. And large enough to provide accurate data means I'm not just going to ask one 6th grader, one 7th grader, and one 8th grader, are you going to the game? I need a sample that's large enough so that I can make a prediction off of it, because not everybody's going to agree. So I need kind of a variety. So reasonable samples, if you have these 3 things, you can use those samples to make predictions about the population. So based on that volleyball sample, I asked 50 people. 10 of them said that they're going to go. I can apply that to the whole school now because it was a reasonable sample. So let's try it. This is a multiple choice question. It says you want to estimate the number of students in a high school who ride the bus to school. Which sample is best? So take a look. So I want students in a high school who ride the bus. Letter A says 4 students in the hallway. Now again, we're looking for random, representative of the population, and large enough to provide accurate data, right? 4 students in the hallway is definitely random. I have no idea if that's representative of the population. I don't know what grade levels that they're in. But do you think 4 students out of an entire high school will be large enough to determine how many people ride the bus? Probably not. So I'm going to say it's not A because it's not large. Or not large enough. When you look at letter B, it says all the students in marching band. Okay, so are all the students in marching band going to represent the entire population? No, it only is one category of student, right? So, no, this doesn't represent the entire population. It's not random because it's everybody in marching band, and it doesn't represent the whole entire population. So it's not random, and it's not, let's just say not population. It's not the entire population. Okay, letter C says 50 seniors at random. Do you know what I know about seniors? Most of them have their driver's license. So if I only ask seniors, that's not going to represent the entire population. It's not random. 50 is pretty large, but I need all 3 to be true. But I'm guessing these seniors aren't riding the bus because they're probably going to drive. So C's not going to do it. It's not going to do it because it doesn't represent the population. So not represent the population. I know I didn't give us a ton of room. That's okay. Hopefully these little notes will help you when you look back to them. If not, you can be more detailed than yours. I don't mind. That would be fabulous. Letter D. I'm guessing it's probably letter D because it's not A, B, or C, but let's make sure. It says 100 students at random. So there's the large enough. There's the random. And it says during multi-grade level lunches. That means it does represent the population. So it's large, it's random, and it represents every single grade level. This would be the one I was looking for. So if you're trying to figure out which one would be best, it's the one that's large, that's random, and that represents everybody. It has a little bit of everybody. All right, last one. We figured out what samples we could use to make predictions, and now we want to actually be able to make a few predictions. So, you ask 75 randomly chosen students how many movies they watch each week. There's 1,200 students in the school. So of these 75 people that you asked randomly, and that seems large, right? And it's random, and I'm guessing you probably asked a little bit of everybody if it was randomly chosen. So it seems like this is a pretty good sample here. And 21 out of those 75 said that they watch 1 movie per week. 30 people said they don't watch any movies per week. And 24 people said they watch 2 or more movies. So now what we want to do is we want to use those values to predict the number of students who watch 1 movie a week. Okay? So we said that 21 people watch 1 movie per week. And it was 21 out of the 75, right? So basically, if I want to predict the number of students who watch 1 movie in a week, I need to know what percent 21 out of 75 is and apply that to the 1,200. So how do you make the 21 out of 75 a percent? The same way you figure out your quiz score when you get it back. You take the part divided by the whole, right? And that gives you the decimal version of the percent, which is what you want. So if I know it's 21 out of 75, then the number of students that watch one movie a week, I'm going to use a variable to represent that amount, is equal to 21 out of 75. That gives me my percent of a decimal as a decimal. And I want to know this percent of 1200. So that word of means multiplication, so all I need to do is take 21 out of 75 and multiply that by 1200. So again, I'm taking the percent as a decimal multiplied by the whole amount. So 21 divided by 75 times 1200. When you do that, and you can just, this means division, so 21 divided by 75 times 1200, that's going to give you 336 people. So based on the entire school population, I know that only 21 out of the 75 said that they watched one movie per week, but if we apply that to the whole school, 336 out of the 1200. If I wanted to figure out how many watched 0 movies, do you know what you would do? You would take the 30 out of the 75, and that gives you the percent as a decimal, and I want to know what percent of 1200, so I would multiply that by 1200. And when you take 30 divided by 75 times 1200, you end up getting 480. So 480 students would watch 0 movies. And if we wanted to know exactly how many watched 2 or more movies, you got it? You know what you would do? You would take the 24 divided by 75 to get the percent as a decimal, 24 out of 75, and multiply that by 1200. And when you take 24 divided by 75 and you multiply it by 1200, you get 384. Now, if you did this right, when you take 480 plus 336 plus 384, you should get 1200, and you do, I promise. So that's how we can use this to make a prediction. Find the percentage by dividing part by whole, and then that gives you the decimal version of the percent, which is what you want, and multiply that by how many students are in the entire population. So the percent of the sample times the population. We'll do more practice in class. Okay, is the prediction appropriate? So that means, do you think that this prediction is kind of right on? Does it give us a pretty close, accurate idea? Well, the prediction will be appropriate if our sample is appropriate. And is our sample appropriate? Well, there's 3 things we need to look for. First of all, is the sample random? Yeah, it said 75 randomly chosen students. So it is random. And then it's supposed to be large, right? 75 students, I think that's pretty large. And if I'm asking 75 students at random, then it's going to represent everybody. So it represents the population. I'm going to write that down here so we can fit it all on there. So the answer is yes. My explanation is it's random, large, and represents the population. We're done. We'll talk more about it tomorrow. See ya.